Well, good morning, good afternoon, everyone. Welcome in from truly across the continent today for another exciting Exploring by the Seat of Your Pants broadcast. If you're joining us for the first time today, I know some of our classes are, we are all about bringing conservation, adventure, and science into classrooms around the world. And you're catching us on a really exciting day because we are on day 4 of 5 in our epic Canadian Environment Week. It's also World Oceans Week. We've got 30 programs with scientists across the country and around the world this week. So do check out the Environment Week lineup, where there's some incredible stuff on climate, polar, fire, and more. And head to our YouTube channel to catch this one and anything else you might want to explore and discover. There is so much to learn and have fun with this week. Now, I'm so excited to welcome back friend of the program and someone who's come on numerous times with us, environment and climate change scientist Zen Mariani. Now, he's going to talk to us today about some of his epic adventures up in Canada's north. This has been a thing that we've been featuring much more in the last few years because there's so much interest from classrooms. Climate change, of course, is something that we're all witnessing right now. We see this impacting the world. And really, there's been a big emphasis on featuring stories from Canada's north, one of the most remote places on planet Earth, still one of the most unpopulated places you can go in the world is straight up from where most of us are today. So I'm really excited to give you the chance to talk to a really amazing storyteller and scientist whose work has taken him up there to share some stories live from the field. Now, without further ado, I'm going to stop talking. Zen, thank you so much for coming back today and for wearing a Blue Jays shirt because I want to support them so much. I really do. It's been tough.
Yeah, it's been tough. It's a tough year. We'll see what happens.
Fingers crossed. Well, yeah. I'm going to zip it, and I know you've got a lot to share, so if you want to bring up screen share and dive in with us, we'll get to it.
Okay, well, great. Thanks so much for having me. This is excellent, and I'm really happy to be here to chat. Can you see my screen okay?
I sure can. You are pretty much good to go. Yes.
Okay, well, thanks very much, everyone. So, yeah, my name is Zen Mariani. I'm a research scientist in Environment and Climate Change Canada, and I work in the Meteorological Research Division. So what does this mean? This basically means I work in a group of people who study the weather. We try to do a better job predicting the weather. So I'm going to talk about my work, which has been focused around studying the Arctic weather and the climate. So firstly, who am I? Well, so I completed high school in Toronto. I'm from Toronto. I went to University of Western Ontario, where I did my bachelor's, my undergrad, and then I went back to Toronto, so University of Toronto, where I did my PhD. And after completing my PhD, I started working as a research scientist at Environment and Climate Change Canada. So this is a picture of me way up in the Arctic, pretty close to the North Pole. And in the background, you can see our research facility there. That's the red building, which I'll talk about in another minute. So let me just go to the next slide here. There we go. So, why are we studying climate change in the Arctic? Well, there's a few points. The first is the Arctic is warming faster than anywhere else in the globe. So that's kind of important. The second is the measurements in the Arctic help us to better understand the changing climate across the whole globe. So what we learn in the Arctic, we apply elsewhere. So this is what my research, when I was doing my PhD, when I was a student at University of Toronto, focused on. I was looking at new measurements of infrared radiation or heat near the North Pole. And it's important because, if we're measuring at a site here, this red line shows the Northwest Passage that's opening up. So as the sea ice melts, this is now sort of going to be an opening route for ships and sea traffic to pass through. So there's a lot of important details in terms of the number of activities that are happening in the Arctic. So when I was a student, my study site was this red building you see at the top left there. It's a place called Eureka. So Eureka is very close to the North Pole. So you can see there's the North Pole there. Eureka is right here at the top of Canada. And it's unique because it's not a normal town. There's no one who actually lives there. There's just the research site. And it's unique as well because, well, if you're in Eureka, there's just you. There's no McDonald's or Tim Hortons. There's no Canadian Tire. You're on your own. So you've got to bring what you need because it's not like you can go down the street to get, I don't know, a donut or anything like that. It's so far north that to get there, what I would do is you take a crazy amount of flights. So we would fly from Toronto to Yellowknife, which is off this map. And then from Yellowknife, we all get on this plane that you can see here, this tiny little plane. We jam it full of all of our instruments and all of our stuff and all the researchers. And then the plane sort of hops from island to island. So there's Cambridge Bay, there's Resolute, and there's Eureka in red there. And so what it does is it has to hop, stop, refuel, and then get back in the air again. And so it's a long trip. It takes hours and hours and hours to get all the way up to Eureka. By the time you get up there, you're pretty tired and hungry. But it's worth it because this is the view when you're up there. So this is us on top of the Ridge Mountain looking. So that's looking sort of west or north. And that's the Arctic Ocean, which you could tell is completely frozen. So this is in sort of the middle of the winter. The sun just rose. And you get these incredible views because almost no one has been there. And it's really a truly pristine environment. So to get around when we're up there, you have to do some pretty different things. It is so cold. One good example is there's so much snow and ice. This is what one of the trucks looked like. It's kind of like a small tank wheels on top of it mounted to a truck, which was pretty cool. And at our site, there are a number of different instruments that were all throughout this building. Most of them are on the roof because we're taking measurements of the weather or of the atmosphere. So we had a whole bunch of instruments, things called sun photometers that look at the sun, things like sun trackers that follow the sun, and different instruments that can measure pollution and trace gases, things like ozone, in and around the entire site. What's really unique about working up in the Arctic is you have something called polar day or polar night. What that means is you're so far north that in the summertime, the sun never sets. So this is what it looks like each hour of the day. And you can see the sun gets low, but it never completely sets. So good luck sleeping when the sun's up all the time. And then if you go in the winter time in the Arctic, which is normally when I went, this is what you see. It's just darkness. The sun never, ever comes up. So you have 24 hours, darkness, no sunlight. So you better bring a flashlight. Some other cool things when you're up in the Arctic is, during polar day, it gets pretty warm. You can get temperatures easily around 15 degrees Celsius. You can walk around in a t-shirt in the middle of summer on a day like today, for instance. Polar night, pretty different. You're at around minus 45, minus 50. It is cold. The other unique thing about the Arctic is I know you see lots of snow, but it's actually a desert. So it receives very little precipitation, very little rain or snow. It's just that when it does snow, it doesn't melt for months and months. And there's no trees. We're north of the tree line. So that's why in all the photos you're mostly seeing rock, snow, maybe some mud. And it is very expensive because if you think, well, there's no trees, there's certainly no orange trees. So if you want any food, you have to ship everything on your plane. So something like orange juice is extremely expensive. It's like $30 at the nearest grocery store in the Arctic just for a tiny little bit of orange juice. One of the cool things when you're up there is there is a ton of wildlife. I mean, this is their land pretty much. So we saw everything from, this is an Arctic wolf in the top left. They're Arctic foxes. That's what you see in the bottom right. And they're very curious because they see these humans and they're thinking, I've never seen a human before. And they want to come up and smell you and see what's going on. There's also, this picture is Arctic hare. So these are like bunny rabbits. This is a caribou. And then you get some great views. The sunsets are spectacular. You've got lots of cool equipment like satellite dishes and radar dishes to try to send our data back down south. So really, really unique views that you get when you're up there. And so here are some more of us at the lab doing our work. And then again, this is a good example of, well, you're working during polar night. So we'd have to strap flashlights to our heads so we could see what we were doing if we needed to get into our instruments and, open things up and move stuff around and try to fix our equipment, because it is a really harsh environment and stuff will break when you're up there. So for my research, I was doing work where we deployed this instrument called an ARRI to Eureka. So that's up here. But what's really cool about this work I was doing in science in general is usually it's collaborative. So you're working with a team. So my instrument was up here, but there are other people from other countries that had the same instrument all across the globe. There's one in Italy, one in Germany, all throughout the United States. Some were on a ship, some were in Antarctica. So this is really cool because it gives you a chance to meet other people from other countries, to go learn about their science. You can talk about your science, and it also helps when you're taking observations, not just at one place, but multiple places across the planet. Now, after I graduated and finished my PhD, so I've been working at Environment Climate Change Canada, and a lot of what I do is with integrated observing system technologies. So that's a very fancy way of saying I take a whole bunch of observations and I put them all together like pieces of a puzzle. So I use data from satellites. I plan satellite missions to go up in space. I use data from aircrafts, weather balloons, even ships. And then we have our sites on the ground. So we have weather stations, we have radars, lidars, a whole bunch of equipment at the different sites all across the country, and we use the data to help inform us about the weather, the atmosphere, the climate, as well as supercomputers. So the data goes to a computer, and that helps us make predictions. And really, one of the goals of my research is to improve our weather forecasts. So just think about turning on your TV. It says, hey, today it's going to be -1, or I mean, hopefully not, but anyways, what we're trying to do is make sure this weather forecast is more accurate, especially as you go out in time. So, 2, 3, 4, 5, 6, 7 days out. That's sort of one of the end goals of what we're trying to achieve. And one of the ways that we're doing this is if we look at our weather forecast, what we do is we take the Earth and we split it into a grid. So these are all little grid boxes, almost like pieces of a pie. And so you see Canada is completely represented by different pieces of this pie. And the weather forecast has different resolutions. So this is what Toronto looked like if we had a map of Toronto and we had a resolution of 10 kilometers. So each square is 10 kilometers. Now, these are pretty big squares. So as you can tell from this picture, you don't really see that much. But if I increase the resolution, if we use a more powerful computer and we basically turn this number 10 into 2.5, so it's a smaller number, I have more squares, more grid boxes. Now we're able to sort of see more stuff. We can see, light blue means it's low altitude. So this is the Lake Ontario. And you can see the darker blue means, okay, there's a hill up here somewhere. And this really helps us improve our forecast for things like extreme heat, rain, winds, air quality events. And what we're moving towards in the now actually is we can increase this further to very high resolution. So this is 250 meter resolution. So what you can resolve, if you can see sort of this feature here of gray, that's the Don Valley River. So we can actually resolve the river that goes into Lake Ontario, and we can resolve the hills and everything that's going around in the city. This really helps us make our predictions for the city. And this is, of course, not just for Toronto. This is what we want to do everywhere. And, well, what does this look like? Well, if we then want to model clouds and say, okay, what do the clouds look like in the forecast? Is it going to rain in a certain location? This is what it looks like in low resolution, 2.5 kilometers. And you see the clouds just look like red blobs. But if we increase the resolution to 250 meters, so now there's a lot more of those pieces of the pie, we've sort of chopped them up into tiny pieces. The clouds now, you can see that there's tiny little red blobs. So there's a more sort of dispersed cloud cover. And if we look at a satellite picture, that's exactly what the clouds should look like. So this looks a lot more like this instead of these giant, massive blobs of clouds that, that's not really what happened. So my research in particular focuses on the Arctic. So I was involved in the Canadian Arctic Weather Science Project, where we had super sites located in Iqaluit, which is in Nunavut, and in Whitehorse, where we were trying to answer these questions you see here. So, weather is a safety issue. So, what are the challenges to forecasting the weather? How can we provide more accurate weather forecasts to the local communities? Because there's lots of people who live up in Iqaluit and Whitehorse and the Arctic in general. And then what's required? What instruments should I put down? And why should I put those there? And we selected these sites because Iqaluit, these green and yellow lines, these are the shipping lanes. And you can see Iqaluit is right in the middle of all the ship traffic. Whitehorse is similar except for the airports for the air traffic. And there's a lot of storms that come across. Some storms even, first they hit Whitehorse, and then they go boom and they hit Iqaluit right afterwards. So if you are interested in severe weather and trying to do a better job of predicting severe weather, think of blizzards, for instance. These are great sites to study that. So our site in Iqaluit was located right next to the runway. So this is the runway you see here. This is the town of Iqaluit. These are all the houses and buildings. Our site was right here, right next to where the planes would come in. And that was really useful because we were able to inform the planes about the weather conditions as they were trying to land or take off. So this is what Iqaluit looks like on the ground in, I think this is October. So this is the fall, and already you can start to see some snow. And it's called the super site because not only do we have our normal instruments measuring, temperature and wind, we also have a whole bunch of special, really fancy, cutting edge tech taking measurements of the atmosphere. We had LIDARs measuring water and winds. We had special cameras that actually can image snowflakes. So each individual snowflake that was falling, we could take that picture, which is really cool. We had weather radar, and we had measurements that measured radiation. So radiation, think of things like heat and how much of the sun's radiation was reaching the surface. We could take all of those measurements at this one location. Now, doing work in the Arctic is challenging. So one example in the top left, you need a lot of computers to record this data, to process it, to transfer it around. You need some heavy equipment. You have to put everything up. You have to maintain it. You have to look after it. And then you've got to, hook it up with power and everything. It's a lot of work outside. And so this is what it looks like at Iqaluit. This is us taking observations on top of a ridge. And this is the town down below with the runway down below. So we actually had two sites at Iqaluit at one point. So the airport is off the image here. But it was really, really interesting to see, what are the differences up on the ridge down by the airport. And last thing to note is this is actually what it looks like when you show up in the winter. So imagine going to work, you show up for work, and to get into your building, this is what you have to dig through first. So you need a shovel or truck, something first you have to get rid of the snow before you can even start your day. So quite a different experience when you're working up in the Arctic. One of the cool instruments that we have in Iqaluit is this LIDAR. It's called a wind LIDAR. And you see the top of it spinning around like crazy. And that's our radar in the background. That's spinning around like crazy too. And it's spinning because it's mapping. It's taking it looks in every direction, and it maps out the winds in and around the city. So you can see the city now. It's nighttime. There's the city in the background. And you can kind of see the ocean, Frobisher Bay there just to the right. And this was taken in September. So you can see that it just rained recently. And then, of course, we also had the opportunity when you're in the Arctic, you can see the northern lights sometimes. And this is a really cool photo because this is a very high-powered LIDAR. A LIDAR uses a laser, and this particular laser was green. So you can see this or this LIDAR is shooting up into space. So we're taking measurements all along the beam at the same time as there was the northern lights. And so this is kind of like shooting a Death Star beam out into space. It looks really awesome when you're up there. So I'll stop there. Thank you very much for your time and your attention. And if there's any questions, please go ahead.
Fantastic, Zen. Thank you so much, man. And if you want to come out of screen share so you can see me again, have a bit of a conversation. Always such a pleasure having you. And I mean, I don't build it up in advance, obviously, because I know that the last slide is coming. It's one of the coolest pictures in any program that we do, and we do like 500 a year. So lasers, aurora, north. It's very cool science. YouTubers, I'll open up the floor to you. If you guys have questions, please do start chiming in. We've had a few already, which is fantastic. So our first one is about these flights. You talked about the effort of getting up there. What's the turbulence like? What's the flying like in a little plane like that? Because it looks kind of dicey.
It is rough. I'll just put it that way. You're in a tiny plane, and there's no bathroom. There's no toilet on this plane, and you can be on there for about 8 hours. So you've got to hold it. The plane is not pressurized. So you normally fly in a plane, they shut the doors, it's nice, it's relatively quiet. Not this plane. It's not pressurized, it's cold, it's loud. So we wear noise canceling headphones, bring some good music or something. And then the last thing about the plane is you're not landing on a nice, smooth runway. You're landing on ice and snow. So it wakes you up, let's put it that way. When you go down for a landing, and it can be pretty bumpy going down in turbulence, I find it fun. It's a free roller coaster ride is the way I look at it.
That's one way of looking at it. I like that very much. I would look at it very differently, but I appreciate the sentiment. There you go, kids. That's what happens when you fly into the farm. 8 hours, no bathrooms, a long time, especially with a jarring landing. That's the last moment you got to hold it. So you get up there, and this segues nicely into our next question. What is the coldest you've ever experienced, or what's the average temperature like when you're up there? A little bit of all the weather Thoughts?
Yeah, I think so. If you're up there in the winter, in the dead of winter, the coldest temperature I ever was in was around minus 54, let's say, maybe 52. But then there's the wind chill. So 52 is not too bad as long as you're dressed properly. But then when you add the wind chill, if it's gusting winds, it's not fun. That's why you have to cover every inch of your skin because you'll get frostbite right away. So that's why your teams, your partner's always making sure that you're safe and that, oh, I don't see any frostbite happening, and you're always checking in with each other because it can be very dangerous.
So we've got some Northwest Territories classes today. In fact, our furthest south is Massachusetts. So I think we all know about wind chill. But I mean, for me, honestly, minus 30 good clothing is so much better than minus 10 with a 30-kilometer wind. Because it
Exactly.
strips the heat right off you. It makes it a very sketchy situation. And again, on the same theme of sketchy situations, so you highlighted wolves. Are you worried about wildlife? Is there any prep that you need to do to account for the fact that there are predators up there that you might encounter when you're out in the field?
Yeah, that's a great question. So the first thing we do is we make sure that everyone always has a walkie-talkie. So if anything happens, you can always call for help. The second thing is you never go for a walk alone. You're always with a team or a partner so that someone's watching your back, you're watching theirs, there's help. You have to really respect wildlife out there because sure, this pack of 20 wolves comes, they look beautiful and you want to pet them, but you have to respect that these are not dogs. These are wolves. They are probably hungry and they're curious. So you've got to sort of keep a safe distance, respect the wildlife. There was a muskox, and they'll charge you. These are muskox, kind of look like bulls almost, and yeah, they'll charge you because they're you're in their land, so they're saying, "Hey, what are you doing there?" The
Yeah.
last thing to know is we do carry bear spray on us. So if there's a polar bear, you have bear spray. I don't know if it would be useful, so I haven't seen a polar bear up there, thankfully, but you've got it just in case.
It's something that we hear a lot about when people go up to the Arctic is that there's some sort of prep. It's always walking together. That's a universal. Bear spray is pretty universal. Sometimes people will have weapons, not so much to shoot an animal, but to scare it off with the sound of it or noise of it. And I mean, there's a lot of prep that goes into a place like this. When we talk to people in India and they're in forests with tigers, same sort of deal. Like it's an unusual thing for 99% of us to think about that you could theoretically be on the food chain. But when you are in a situation like that, it all sort of boils down to respecting those animals. And I love that. So thank you. um, Might be an easy one, might be a hard one. Is there a favorite part of what you get to do? Is there, I mean, there's obviously, as with all scientists, the diversity of things that you get to do on a day-by-day basis throughout a year. Is there something that like, oh, that's my favorite thing. I love crash landing after the turbulence, maybe, or something.
I think one of the nicest things about the job that I do in particular is you really get to travel a lot. So you get to see the whole world, basically. Some of that is to do, the Arctic is a great example, but then um, you get to go to other places across the globe. And so you get to see what is it like in South Korea and Hong Kong and Australia, and you get to talk and work with some of the scientists, kind of like your equivalent in another country,
Yeah.
which is just amazing because you're learning not just about other countries and other peoples and other cultures, but you're also seeing, what are the scientific problems that you're facing, and how are you addressing that, and what can we learn from you, and what can they learn from us, and how can we help each other that way? Because sure, there's some problems that are global and everyone's trying to tackle the problem the same way, but there's other issues that can be very local, and so you're trying to apply the same lessons in different parts of the world.
I'm going to harp on this for a minute because this is something that I always love to feature when scientists bring it up. So you have the chance to go to these other places. Do you have scientists coming and working with you in the Arctic? Do you have collaborators from Europe, Asia, Australia, etc.? And what is that process like to get them up there, if so?
Yeah, I think so. We worked very closely with the World Meteorological Organization. So it's, all the countries are together, and in the Arctic in particular, um, depending on the project. Yeah, I just finished a project where we were working very closely with countries like Norway, Sweden, so some of the other Arctic countries. Um, Getting them up to the Arctic is a challenge. The number one problem is it's so expensive to get up there. So a lot of our collaborations are done, like this: phone calls, remotely. If we can get someone up there, if someone has some really cool piece of technology, they want to deploy it, and hey, let's test it out, let's see it now. Then yeah, we do that. They'll fly into Toronto first. We test things out here. We get everything together, and then we all sort of travel up there together and deploy it and see how it works.
How cool is that? It's one of my very favorite things. I mean, whether you're an Arctic scientist or a deep sea biologist, astronomer, astronaut, whatever, people collaborate together. Like if you end up in science, you get to work with the coolest people around the world, get to go to cool places, work with really intelligent people, come up with problem solving together. It's really an exciting adventure. So great follow up on this in your answer there. Getting the materials up there. So you talked about stuffing the plane super full, island hopping. How are they getting the fuel there, the food there? Like, are there depots that ships drop things off at, or like, do you have any sense of the logistics of all of this?
The logistics are a nightmare. So, but you have to do it. I mean, otherwise nothing's going to work. So what you normally do is everything has to be planned over a year in advance.
Wow.
So, which goes back to this idea of if any work you do in the Arctic, you really have to plan. What do I need? Because you can't just walk across the street and go to the Canadian Tire or Esso station. So what typically happens in the Arctic is around this time of year in the summer, there's something called sea lift. So these cargo ships go up and they go from community to community and they drop off the big equipment, the big supplies. Think of things like diesel, fuel, gas, that kind of stuff. So then once it's there, now you have fuel so that when your plane comes in and lands, it can refuel. And that's basically the gist of it. But yeah, you really have to plan well ahead because you can't bring everything on the plane. Some stuff you have to send up in advance.
Yeah. I'm so glad you mentioned sea lift. So where I am in Western Newfoundland, we actually have people that work near me that do exactly that. Like they call them milk runs. Like they go up for like 2-3 months and they do all the little communities, pond inlet, middle of, nowhere really. Like it's thousands of miles of shipping to get these materials to these places. But it enables all this and enables communities to survive. And it's something we haven't referenced very much in our history. I also like that you're doing a plug for like every Canadian chain at this point. We've snuck in Tim Hortons, Canadian Tire. Like if you want to keep throwing in some like product placement, I'm all in for it.
Yeah, there we go.
Since you've been going up, I love this question. Have you noticed changes? So, I mean, what's interesting is when I was a boy, climate change was this like distant thing. And now we see it every year. It's the hottest year. It's the wettest year. It's the driest, the biggest fires. In your experience in the Arctic, have you witnessed things change over time? And what can you speak to?
Yeah, I'd say there's two elements to that. The first is if we just look at the data that we've been collecting, there's a very clear signal, over the past 10, 20, 30 years, just the data set, the same site, the same instrument, collecting the same way. I mean, I'm generalizing. You can see these trends, these changes occurring. You can see the increasing, let's say, temperature is an obvious one. So it's in the data, and there's a ton of studies that have looked at that have published it, that have explained, why is it happening this way and that way, and the magnitude of those changes. So that's definitely there. Another thing that we've started to see very recently are weather phenomena that typically happen elsewhere. A good example is there's something called atmospheric rivers. So these are these masses of air that are very moist, lots of water vapor in the air, and lots of wind. And that typically hits Vancouver, the West Coast. There's been flooding because of that. Well, we're starting to see those happen in the Arctic, which doesn't, we're talking about a once in 100-year event, and it's happening more and more frequently. So we're seeing those changes. Other than that, yeah, there is the, I'm walking around outside in the Arctic in t-shirt and shorts in, not the peak of summer, and that's a little odd, but that could also be a one-off, right? So that's when you really have to look at the data.
Well, and so you mentioned this once in 100-year event, and one thing that's, it's funny, but it's not funny, is like these once in 100 or once in 1,000-year events are like, oh, every 3 years now. It's like, oh, we're gonna have to change how we describe that. I literally, I moved to Newfoundland from Ontario, from Toronto, and I call Newfoundland weather nostalgia weather because it's exactly what it used to be like in Toronto 20 years ago. And now it's radically hotter in the summer, radically cloudier in the winter. And I mean, I'm sure the data bears this out, but I mean, that is the experience now. Is it's totally different. So it's kind of nice to have moved further north in a place where it's more similar to what I remember as a kid, because I think we all sort of get used to the standard weather.
Yeah.
That's a cool question. Thanks, guys. Zen, I don't want to keep you all day. Time flies when you're having fun. We've had a good long Q&A. I love this question to wrap up, which is, what's next? Where are you going? Are you going somewhere in the summer for work? And what's the next adventure?
Yeah, so we have a trip planned where I'll be back in Iqaluit this summer, probably in August. The reason why we're going in August is we have to do some of the bigger work outside, dig stuff up, fix up some instruments, put in some new instruments. It's a lot easier to do that work in the summer for a million reasons. So yeah, I'll be up there in August. I go with a team from Environment Climate Change Canada. We go with an engineer, a technician, and what we're doing is at this trip, it's repair. So you're putting stuff in the Arctic. It's an extremely harsh environment. Stuff's going to break. So we've got to go up. We have to fix some stuff. We have to maintain some stuff. We've got to, and then once you do that, you have to calibrate it. So you can't just, I fixed it, turn it on, and walk away. Well, you have to make sure this instrument is doing what you think it's doing, that it's still accurate and precise the way you expect it to be. And you have to test things out. So you have to stay up there and make sure, it's doing the right things. So yeah, I'll be up there in August and we'll be collecting the data. Then hopefully it'll be back up and all our data is open and live and you can access it in real time.
I've got a quick follow-up to this. I lied about this being the last thing. So one is just to note, engineer and technician. It's worth emphasizing that you do not need to be a PhD in science to end up doing some of these cool roles, whether it's Arctic research or what have you. Like there are cooks, there are engineers, there are storytellers, photographers. I mean, there's a ton of different jobs that allow you to have experiences like Zen. So whatever your passion may be, that's just an important note. And my follow-up is, so calibrating, you've got this machine, like one device that's measuring things and you fix it. Do you have to bring up a second device and plug that in to be able to be like, okay, they match? And we know this other one works. Like, how do you calibrate it when there's one of something out at a remote location?
Yeah, I mean, that's a great question. So yes, ideally you would have two, or three, put them all together. Okay, they all agree. And we can do that for certain things, but for some of the other instruments, there's ways of calibrating it where you can give it a known target. I'll give an example. If I want to calibrate a LiDAR's distance, I'll know, okay, the distance between the LiDAR and that building is, let's call it 100 meters. So I'll shoot the beam at the building and the data will say, yeah, it's 101 meters. And okay, so I know it's pretty close, but it's off by a meter, and then we can calibrate it properly. So that's just one example. If there's other ways and tools you can go about calibrating some of your instruments where you don't always have to have sort of multiple co-located instruments.
Cool. Thank you for that. That was just a bit of personal curiosity. Much appreciated. Zen, is there any last message you want to leave about your work, about going up on these expeditions, about environment, climate change, research generally, anything to leave us with before we say farewell together?
No, just, thanks very much for having me. I think this is great. It's great that your classes are interested and engaged, because I think that's the most important thing is communication, talking about this with your friends, your families. And actually, Jesse, you raised a great point. It's not, you don't have to be go this one route and PhD and to get these opportunities. Nothing I do would work without the teamwork. Nutritionists, engineers, there's computer scientists, people who code all day because they love computers. There's a whole team of people that are doing this work together. And that's, so to that point, it's just, if you can find out what you want to do and what you love and put those two things together, then you can open some great doors like this.
No better message than that, Zen. Thank you so much for your time, your expertise, and passion. I hope you have a marvelous time up in the summer. And for now, we'll say a big thank you for joining us during our World Environment Week, and have a wonderful rest of your day. Bye for now to you.